Hello and welcome, coming to you not quite live from One Take Studios, where today we are talking about multiplying and dividing rational expressions, which I kind of enjoy, believe it or not. I know, I'm a little bit strange, but rational, a lot of people struggle with that word because they don't always remember what it means. Please remember that root words can be helpful. What do we see right here? First 5 letters, we see ratio. That's a comparison of numbers, often written as a fraction. Ladies and gentlemen, this means that we are talking about fractions today. Multiplying and dividing fractions, to be exact. I know, you're excited, I can tell. Alright, so I want to start with a couple of interesting ideas here. Let's say for the fun of it that we have this delightful rational expression. Okay, we've got x plus 2 over x plus 3. There are a huge number of humans on this planet that have something in the back of their brain going, I can cancel this. Alright, so I'm going to cancel this x with this x, and those will be gone, and that way I'll just be left with 2 over 3, and that'll be the nice simplified version of that fraction. Most people, many people, a lot of people, think that that's okay. Because it looks okay, so it's probably okay. Okay? Let's take 6/7, shall we? Just for the fun of it, I'm going to rewrite. Let's see, 6 is the same thing as 4 plus 2, and 7 is the same thing as 4 plus 3. So if you'll notice, I've now made this look a lot like my previous fraction, and let's see if we can follow the same logic to a delightful conclusion. The 4 here can cancel out with the 4 here, leaving you with 2 over 3. Consequently, that means that 6 over 7 and 2 over 3 have the same value. Except that they don't. They do not. Ladies and gentlemen, 6/7 is like 0.85 something. This is 0.666667. You cannot just cancel things between top and bottom because you feel like it. There has to be a specific structure to it. So it's not good enough for your brain to remember part of something sort of and apply it. So this right here, all of this is all bad, rawr, okay? We can't do this. So what can we do? Ladies and gentlemen, huge first note to self, you can only cancel factors. Factors are the only things that you're allowed to cancel. Some of you don't know what factors are. Okay, so let's deal with that. These are not factors, which is why this didn't work here. Factors are things that you multiply. So I can cancel things that are being multiplied together. That's addition. That's addition. All addition. I can't cancel things that are being added. I can't cancel things that are being subtracted. I can only cancel factors, things that you multiply. Alright, so let's turn to 8/12, shall we? And let's see if we can come up with some comparisons here. Allow me to rewrite 8 as 4 times 2. 4 times 2 is 8. And allow me to please rewrite 12 as 4 times 3, because 4 times 3 is 12. Notice again I'm running parallel to a previous example, but the difference is this was adding and this is multiplying. What happens now if I cancel my 4's, which are factors? They're things that are being multiplied. I now get 2/3. Which actually has the same value as 8 over 12. If I divide 8 over 12 and divide 2/3, I'm going to get the same value for both. This actually works. This is correct. All right, this is happiness and joy. Oh, look at the happiness and joy. All right, right there. So I cannot cancel things being added and subtracted. I can only cancel factors, things that are being multiplied. Therefore, when you head into these problems, oftentimes you feel like you are heading into battle, I would recommend the following battle cry. Dun, dun, dun! Factor and cancel. Yell it, scream it. Run through the streets. It'll entertain your neighbors. It'll be great. Factor and cancel. If we're going to be multiplying and dividing, that is our entire game plan. Factor and cancel. Because I can't cancel unless I have factors. Alright, so that being said, let's look at a couple of examples, shall we? Because life always gets more complicated than just doing 8 over 12. Alright, so let's do some simplifying here, and if we are simplifying, we're going to start with this delightful gem right here. So I've got 2x to the 4th times y over 3y to the 8th times 15z squared over x cubed. Okay, notice what we have here. That's a multiplication sign, all of it's multiplying, there's some division going on. There's all factors here. I don't have to worry about adding and subtracting stuff, so I can start canceling things. Because problems get a little bit complicated, I actually prefer to multiply my fractions together first, and then do my canceling, just so that I don't accidentally lose track of something. How do you multiply fractions? You should already know this. You multiply the top times the top straight across, and bottom times bottom straight across. So 2 times 15 is 30, and then that's going to be, let's see, we've got an x to the 4th there, we've got a y, we've got a z squared, over, let's see the bottom, I've got a 3, and I've got a y to the 8th, and I've got an x squared. Ooh, humor me, because I'm going to show you something. Commutative property. I can multiply things in any order. I'm going to put the x cubed next, and I'm going to put the y to the 8th on the end of this one. All right, why would I do such a thing? In my brain, I like to stripe my problems. All right, here's my numbers, here's my x's, here's my y's. All right, and so I'm kind of working on simplifying each piece of this. We get so caught up sometimes in our properties of exponents that we forget that 30 divided by 3 is 10, because 30 divided by 3 is 10. So 10 is part of my answer. Okay, well, what else do we have here? We've got x to the 4th over x cubed. If we're dividing, same base, we subtract the exponents, all those things still work. However, visually, my brain pictures 4x's being multiplied on top and 3x's being multiplied on the bottom. And if 3 of those sets of x's cancel out, what's left and where? I will have 1x left for my numerator. Well, what about the y's? This is y to the 1st over y to the 8th. Again, if I just picture this, I can cancel this one y with one of these y's, leaving me with 8 y's being multiplied, 7 y's being multiplied on the bottom. There we go. Again, properties of exponents, 1 minus 8 is negative 7, hence there's the reciprocal for the bottom there. And z squared has nothing to cancel with, so it's just going to be z squared. Ladies and gents, that would be my simplified version of that particular problem. All right, so we are multiplying rational expressions. This is what that could look like. Maybe, depending on circumstances. However, circumstances change. We all know this. So let's check out the next problem, shall we? Let's see, I've got some space here. Yep, okay. This is x minus 3 over 4x plus 20 times x plus 5 over x squared minus 9. Do you have warning bells going off in your head right now? 'Cause you really, really should. I can't start canceling this x with this x, or this one with this one, or this 5 with this 20, because I can only cancel factors. Factor and cancel. This is my battle cry, people, all right? Here, I had all factors. It was good. But this, I don't have factors yet. But it's a good thing that I know how to factor, because I can create some factors. I can make this happen. All right, so what is this going to look like? This is going to be x minus 3 is just going to be x minus 3. Ooh, but here, 4x plus 20, I can pull a 4 out of that. And that would leave me with x plus 5. So what am I really looking at the moment? 4 is a factor, and x plus 5 is a factor. And quite frankly, as long as I keep it as what I call a chunky factor, x minus 3 can also be a factor, because if you think, I am multiplying this, so x minus 3 is a factor if I keep it intact as a solid piece. I can't go work with the x and the 3 separately, because those are not factors, but as a giant piece, it'll make some sense here. So my second fraction, x plus 5, I can't cancel x plus 5, can't factor x plus 5, therefore x plus 5 will be another one of my chunky factors here. And let's see here, x squared minus 9, ooh, difference of squares. That's going to be x plus 3 and x minus 3, squeeze edge of the page. There we go. All right, so again, those are my factors. Factor and cancel. All right, again, this happens as long as I can cancel something between top and bottom, it's going to work. I have an x minus 3 on top, I have an x minus 3 on the bottom. Say goodbye, gone, there we go. Ooh, what else? I have an x plus 5 here on the top and an x plus 5 here on the bottom. Also gone. Whatever's left is my answer. And because we're multiplying, again, we just multiply straight across. Wait a minute. I canceled everything on top. What's left? Well, okay, so think. Just think for a second. What is x minus 3 divided by x minus 3? 1. I'm not going to have nothing left in my numerator. I have 1. That's as a result of my canceling. There we go. And this is just going to be 4 times x plus 3. So 4 times x plus 3. Those are the factors that remain that couldn't cancel with anything. Therefore, that is it. Ta-dun, ta-dun. Okay, factor and cancel. That is the game plan. That is the battle cry. That's all we got right there. Now, I do want to consider one thing with you here briefly. What is the one number that you can't divide by? Do you remember that? You can divide by any number on the plan except for 0. Is there any number that would make this denominator equal to 0? Chances are 4 is not going to be 0. But this is x plus 3. Is there any way for x plus 3 to equal 0? Yeah. If x was negative 3, that would be problematic. Therefore, we're going to stop and pause for a moment and say that x cannot equal negative 3. X cannot equal negative 3 because this particular expression would be undefined at negative 3. In other words, it has no value at negative 3, therefore x cannot equal negative 3. We're pointing this out now. It's actually going to make more of a difference when we get into graphing, which is not quite yet, but it's something to be aware of. So if you wanted to go back up here, you could also say that y couldn't equal 0. But if you want to be picky, you should go all the way back up here. You would also have to say that x couldn't equal 0. Because at any point in time, if there's anything in your problem that would cause x to equal 0, it's problematic. Did you hear that? If you go back, at any point in time, if there's anything that would cause x to equal 0. Ooh, guys, guess what x also cannot be? It cannot be negative 5, because that would be problematic right there. And it can't be 3, because that would be problematic as well, right there. So if there's at any point in time, anywhere in the problem, a number that would cause your denominator equal to 0, it's undefined at all those places, at negative 3, at positive 3, and at negative 5. All right, so all of these are just kind of things to be aware of that cause problems with the denominator. Okay, okie dokie. Let's see here. Got 2 more examples I want to run here for you. Next one up says, ta-da, simplify again. Oh, what is all of that? Okay, 2 things you should notice. 1, ooh, it's scary. None of these are not factors right now. This is all going to have to be factored, otherwise we can't cancel anything, all right? Factor and cancel, this is our battle cry. But this is also a division sign, and this is multiplying and dividing. We've done all multiplication up to this point, so we're going to have to deal with the division sign as well as we progress here. I'm going to start with some factoring here, just to make my life a little bit better. If I look at these first 2, I can pull out an x squared, so I'm going to do that. Leaving me with x squared minus 9. Ooh, I know, I see it. I'll come back to it later. And then these guys, let's see, what's that going to have to be? That's going to have to be x minus 3 and x minus 1, because that's going to give me what I need there. Divided by, this is going to be, ooh, I can pull out another x squared here. So that'll leave me with x squared plus 2x minus 8, and we're going to have to come back for that guy. And then, ooh, x squared minus 16, again, that's difference of squares, x minus 4 and x plus 4. Okay. All right. Can we do double duty on this next line here? I want to finish taking some of these apart because they're not fully factored yet, but I also want to deal with this division sign that we've got here. First fraction, let's leave it x squared. But let's call the x squared minus 9, let's call that x minus 3 and x plus 3, because again, that is difference of squares. And denominator on that one was good at x minus 3 and x minus 1. All right, now, when I go to approach the second fraction, how do I divide? Multiply by the reciprocal. So this goes from being a division problem to a multiplication problem. But what was on my denominator is now going to be in the numerator. So this is now going to be x minus 4 times x plus 4. Again, we are dividing, which means we are multiplying by the reciprocal. So I'm going to flip this other dude to the bottom then. I'm going to keep that x squared, but then, let's go with x plus 4 and x minus 2, because that'll give me what I need for that one. If you struggle with factoring, you need to go back and practice your factoring, because if you cannot factor as well as you can breathe at this point in time, this is going to be really intimidating, and your homework is going to take forever. And while some people would enjoy spending forever in math, maybe that's not you. Okay, so factor and cancel. We have factored. Now what can we do? We can cancel. Ooh, how many things can we make go away? Let's see. There's an x minus 3 on the top and x minus 3 on the bottom. Gone. X plus 4 over here, x plus 4 over there. Gone. Ooh, there's an x squared here and an x squared there. That's gone. I like crossing things off. Did I run out of things to cancel? I think I might have. So therefore, I'm just going to squish together what I have left. I've got an x plus 3 in my numerator. I've got an x minus 4 in my numerator. And then over what's left here, I have an x minus 1 in my denominator, and I have an x minus 2 in my denominator. Those are the factors that remain that did not cancel. Therefore, that, ladies and gents, is it right there. That is as simple as it gets. Just remembering our conversation about things being undefined, is there any value here that x cannot equal? Well, kind of run your way back through the problem. X can't equal 3, or 1, or 4, or negative 4, or 0, or 2. So there's a lot of places where this one would be undefined. Okie dokie. Last thing, change of directions. What if we are going to solve instead? All right, so what if we are going to solve instead? Let me give me a nice separation line between problems here, so we got some space. Okay. This time we are solving x squared plus 3x minus 10, and that's over x minus 2 equals 7. Well, why might this come to my advantage with this whole process that we've just been through? Couldn't I just put the 7 over 1 and cross multiply? Yes, I could do all those things. However, if you pause and check your factors, you might see something you like. X squared plus 3x minus 10. That could be x plus 5 times x minus 2. Right? That's going to work. Over x minus 2. Again, x minus 2 doesn't factor, therefore it is a factor, and this equals 7. Well, check this out. Again, gone, gone, gone. What's left? All we have left is x plus 5 equals 7. Isn't that so much easier than cross-multiplying and foiling and factoring and all that kind of craziness? Subtract 5 from both sides, x equals 2. Cool. We're done. Or are we? I don't know. That was boxed because that one's done. This isn't boxed yet. There must be something wrong. Oh, we just had that discussion, didn't we? We can't divide by 0. What happens if x equals 2? That's undefined. So the only answer we have is undefined. The only answer we have, we can't have. This is another one of those extraneous solutions. Extraneous, which we also saw with logarithms. Okay, extraneous solution means we didn't do anything wrong, and it is a solution. It's just not a solution that actually works, so we don't get to keep it. It's kind of like a fish that we're going to throw back. All right, so x equals 2 is an extraneous solution. It does not work. We cannot keep it. Therefore, there is actually no solution to this equation. All right, so couple twists and turns along the way. Your factoring skills, they've got to be good. They've got to be solid. Remember, this right here, this page contains everything in a nutshell that you need. You cannot cancel things that are being added, subtracted. You can only cancel factors. So factor and cancel, boom. If you are multiplying, dividing rational expressions, this is your life right here. Yell it, scream it. You've got it. Have fun.